Hello everyone, imagine that we are all sitting together outdoors on a clear night, with a gentle breeze drifting by carrying the fresh scent of damp earth after a recent rain shower, and above us stretches an immense sky sparkling with countless stars that seem to whisper ancient tales about the vast universe beyond our world. It is now the year 2025, and time has flown by so quickly. In just the blink of an eye, we have officially entered a brand new year filled with wonderful mysteries and possibilities waiting to unfold ahead of us. Allow me to share with you some of the most fascinating cosmic events that will take place over the next 5 years, those special moments when all you need to do is look up at the sky to feel the grand majesty of nature, accompanied by the soft whistling of the wind and the distant twinkling lights from far away in space. And woven throughout these wonders is the even greater story of the Artemis mission, humanity's ambitious journey to return to the moon, not just to set foot there briefly but to stay, to build lasting structures, and to dream of reaching new horizons even farther out. Right from the early days of this year, specifically in the months of January and February, we will have the opportunity to witness a beautiful parade of planets across the night sky. Picture this scene. As darkness falls and the air turns cool enough to make you pull on an extra warm jacket, 6 massive planets, those enormous spheres spinning wildly through the emptiness of space, will align in a perfect arc, forming a graceful curve of light against the deep black backdrop of the heavens. This is when Mercury, Venus, Mars, Jupiter, Saturn, and possibly even Uranus will all appear together, creating a rare and breathtaking sight that will make your heart beat faster with a mix of awe and excitement. All you need to do is find a spot far from the bright lights of the city, lie back on a soft blanket of grass, and let your eyes follow each planet as it shines brightly, almost as if they are dancing in the sky just to greet us on Earth. To make the experience even more enjoyable, consider bringing a simple pair of binoculars or a small telescope, which can reveal details like the rings of Saturn or the reddish hue of Mars, turning a simple evening into an unforgettable adventure in stargazing. Then, on the 12th of August in the year 2026, one of the most spectacular astronomical phenomena will occur, a total solar eclipse. Think about that incredible moment when the moon slowly moves in front of the sun, completely blocking its brilliant daytime light. The sky will suddenly grow dark in the middle of the day, the temperature will drop noticeably, causing goosebumps on your skin, birds will stop their singing as they mistakenly believe night has arrived, and a magnificent halo of light will surround the dark silhouette of the moon. This is when you truly sense how fragile our planet is, especially if you position yourself in a location like Greenland or Spain to observe it, with cold winds blowing through and crowds of people around you murmuring in wonder and amazement. This total solar eclipse comes after many years of anticipation, and it will last for several precious minutes, leaving you with an overwhelming feeling of respect for the immense power of the universe. For those planning to travel, remember to prepare eclipse glasses for safety, and note that the path of totality will cross over parts of Europe, offering a chance for millions to share in this shared human experience that has captivated observers for centuries. But that is not all. In August of 2027, a visitor from the depths of space will pay us a close call, a gigantic asteroid with a diameter of about 1 kilometer, known by the name 1999 AN10. It will pass by Earth at a distance of merely 300,000 kilometers, which is closer than the average distance from our planet to the moon. Imagine peering through a telescope with your heart pounding from a blend of worry and thrill as this massive rocky body hurtles past at an astonishing speed, leaving a faint trail of light across the night sky. Fortunately, it will not collide with us, but its proximity serves as a strong reminder of the potential threats lurking in space, and scientists are monitoring it closely with advanced radars and telescopes to ensure our safety. This event highlights the importance of planetary defense programs, where organizations like NASA use spacecraft to study and even deflect asteroids if necessary, protecting future generations from cosmic hazards. And flowing through all these years, from 2025 to 2028 and beyond, the Artemis mission unfolds like a grand symphony composed by humanity itself, a program that goes far beyond simply returning to the moon. It is about shaping the future of space exploration for generations to come. Picture yourself in NASA's control room, with screens glowing with streams of data, The hushed voices of engineers filling the air with a mix of tension and enthusiasm, and then the massive rockets roaring to life as they lift off, carrying the dreams of humankind toward the stars. Artemis is not just a single flight, it is an extensive, long-term journey named after the Greek goddess of hunting, who was the sister of Apollo, paying homage to the historic missions of 1969, but this time we are not merely stopping for a visit, we are planning to remain, to construct habitats, and to expand our presence outward. To fully appreciate this, let us step back in time for a moment to understand the background. After the Apollo 17 mission in 1972, which was the last time humans walked on the Moon with astronaut Eugene Cernan leaving the final human footprints in the dusty surface that have remained untouched for over half a century, we said a temporary goodbye to our celestial neighbor. The atmosphere on Earth back then was a blend of jubilation and sadness. Millions watched on black and white televisions, applause echoed through the control center in Houston, but wars, economic challenges, and shifting priorities caused the space program to pause for decades. Now, in 2025, with explosive advancements in technology such as artificial intelligence aiding spacecraft design and high-efficiency solar panels powering missions, NASA, led by figures like Administrator Bill Nelson, has revived that dream through Artemis. The program was officially announced in 2019 with an initial budget exceeding $93 billion for the early phases, and by now, with the latest updates from the United States Congress in 2024, it has received billions more in funding, collaborating closely with international partners including the European Space Agency, Japan's JAXA, Canada's CSA, and private companies like Elon Musk's SpaceX and Jeff Bezos's Blue Origin. This is a truly global effort, where engineers from numerous countries work through the night, exchanging ideas in virtual meetings filled with laughter and passionate debates, all united in the goal of returning humans to the Moon in a more diverse, sustainable, and Mars-oriented way. These partnerships not only share costs but also bring diverse expertise, from Europe's robotic arms to Japan's precision instruments, making the mission stronger and more innovative. Now, let us delve deeper into the core of Artemis, the specific missions, numbered in sequence like chapters in an epic adventure story. Artemis I, successfully completed in November 2022, was the crucial first step without any crew on board, a dramatic test that had everyone holding their breath. Envision the Space Launch System rocket, a beast taller than the Statue of Liberty by 4 times and weighing over 2,600 tons of fuel, thundering upward from the Kennedy Space Center in Florida under a clear blue sky filled with billowing white smoke. The Orion spacecraft, with its sleek oval shape and heat shield made from super-durable materials, orbited the Moon for more than 25 days, testing propulsion systems, radiation shields, and survival capabilities in deep space. Though no astronauts were aboard, it carried test mannequins named Helga, Zohar, and Campos, representing both women and men, to measure G-forces and cosmic radiation levels. When Orion returned, plunging through the atmosphere at 11 kilometers per second with its shield glowing at 2,800 degrees Celsius like the surface of the Sun, it splashed down in the Pacific Ocean amid crashing waves and rescue helicopters rushing in, prompting cheers of triumph from the teams. Data from this mission, updated through 2025, has refined systems, lowered risks for crewed flights, and proven that Orion can shield astronauts from solar radiation storms, those bursts of protons that could cause cancer without proper protection. This success paved the way for reusable technologies and inspired new generations of engineers. Following that is Artemis II, scheduled to launch in late 2025 or early 2026, right around the time we are discussing this. This will be the first crewed mission since the Apollo era, featuring 4 brave astronauts: Commander Reed Wiseman, pilot Victor Glover, who will be the first person of color to fly to the Moon, mission specialist Jeremy Hansen from Canada, and Christina Koch, a NASA engineer with a record-breaking stay on the International Space Station. Imagine the moment they strap into Orion, their hearts racing beneath their suits, as the Space Launch System engines roar like thunder, propelling them on a loop around the Moon at a distance of 80 kilometers, close enough to see the gray impact craters and rugged mountains bathed in unfiltered sunlight. They will not land but will fly by, testing laser communications with Earth, observing phenomena like eclipses from a space perspective, and experiencing the profound isolation of gazing back at our small blue planet suspended in the endless black void. Emotions will surely surge: national pride, homesickness upon seeing familiar continents, and deep reverence for the infinite cosmos. With the most recent updates from NASA in October 2025, the mission has finished its final integration tests, and the crew is training in virtual reality simulations at the Johnson Space Center, enduring zero gravity and simulated alarms to build unbreakable team bonds like a family among the stars. This mission also includes experiments on human health in space, monitoring everything from bone density to psychological well-being. Then comes Artemis 3, the pinnacle mission in 2026 or slightly later, marking the return of humans to the lunar surface after 53 years and NASA's first landing in over 4 decades, as I mentioned earlier. Using SpaceX's Starship, a reusable giant capable of carrying 100 people and successfully tested in flights during 2024, astronauts will touch down in the Moon's south polar region, where water ice hides in the permanent shadows of deep craters. Visualize the scene: white XEMU spacesuits that are heavy yet flexible with carbon joints, taking slow steps on the fine, sparkling dust that clings like diamond powder under the harsh sunlight. This time, a woman and a person of color will be among the first, possibly Jessica Watkins or another from the Artemis generation, collecting rock samples, setting up scientific instruments, and even testing 3-dimensional printing from lunar regolith to build shelters. Sounds: utter silence except for your breathing through the helmet, the soft crunch of boots sinking into dust, and radio voices from Houston saying, "Earth to Moon, you are there." The scientific goals are enormous: studying the solar system's origins through ancient samples, testing resources for hydrogen-oxygen fuel, and preparing for long-term habitation. By 2025, using data from the Lunar Reconnaissance Orbiter with the latest updates, NASA has pinpointed the exact site near Shackleton crater, where prolonged sunlight keeps solar panels running continuously, avoiding the risks of shadows dropping to -230°C. The astronauts will land on the dusty, grey lunar surface where the quiet is so profound you can hear your own breath echoing in the spacesuit. The objectives extend beyond footsteps to establishing permanent bases, constructing living modules with warm artificial lighting where humans can research resources like the South Pole's water ice. Envision robots digging under the intense, unfiltered sunlight, and astronauts moving slowly in low gravity, feeling as if they are dancing on another world, ushering in a new era of space exploration. Additional plans include deploying rovers to map ice deposits and conducting biology experiments to see if microbes can survive lunar conditions. However, Artemis does not end there. It serves as the foundation for the future. Artemis 4 in 2027 will deliver the Gateway module, a small space station orbiting the Moon like a pit stop with laboratories, fuel depots, and accommodations for 6 people, built by the European Space Agency and JAXA, featuring enormous sparkling solar arrays. Think of it as a home in the void, inside warm with soft blue LED lights, astronauts eating tasty freeze-dried meals, watching Earth rise and set every 28 days, feeling isolated yet connected via video calls with loved ones. Gateway will bridge to longer missions, testing life support systems that recycle water from breath, and even growing vegetables in hydroponic gardens under artificial lights. This station will enable refueling stops and serve as a hub for international crews, fostering cooperation that could extend to joint Mars planning. Looking even further, Artemis aims for the 2030s with permanent lunar bases, settlements under domes shielded by compressed lunar soil against radiation, autonomous robots mining at night to escape extreme temperatures, and space elevators from Gateway to the surface for cargo transport. The latest updates from the 2025 Artemis Accords Conference show 45 countries signed on, including Vietnam, through research collaborations, expanding the global network. Costs run into tens of billions of dollars, but the benefits are invaluable. Spin-off technologies like improved lithium batteries for electric vehicles, space medicine combating osteoporosis, and inspiration for young people. Those children today lying in bed gazing at stars dreaming of becoming astronauts. Educational programs tied to Artemis reach schools worldwide, teaching STEM subjects through real mission data. The emotions behind it all stem from human resilience. Astronauts like Koch, who spent 328 days on the International Space Station, speak of missing the aroma of morning coffee or children's laughter but finding joy in cosmic sunrises. Engineers in humid Houston labs share stories of setbacks, like the 2023 Space Launch System delays due to technical issues, yet overcoming them with the motto that failure is not an option. Environments range from Florida launch pads with distant seagull cries to Arizona deserts where crews practice moonwalks on rough terrain. The mental image, Earth from the moon, a fragile blue marble hanging in space, reminding us of our home's vulnerability and beauty, urging planetary protection while we conquer new worlds. These experiences build not just technical skills but a profound sense of unity across borders. By 2029, we will face the most dangerous asteroid of this generation, Apophis, a rock 340 meters wide. It will skim past Earth at just 32,000 kilometers, closer than geostationary satellites. This ultra-rare event happens once every 10,000 years, and you can spot it with the naked eye on Friday the 13th of April that year, a symbolically charged date named after the ancient Egyptian god of chaos. Picture that night with clear skies and a bright point moving swiftly, drawing eyes from Europe to Africa in excitement and anxiety. Latest NASA calculations from 2021 updated to 2025 confirm no impact, but it nearly passed through a gravitational keyhole that could alter its path for a 2036 collision, keeping scientists awake. If it exploded in the atmosphere, the power equals thousands of tons of TNT, wiping out 2,000 square kilometers. Ground impact creates kilometer-deep craters, widespread earthquakes, and 100-meter tsunamis flooding coasts. Yet with data from the OSIRIS-RX mission and new observations, we are reassured, though monitoring continues to learn planetary defense. Future missions like DART's successor will practice deflection techniques, ensuring readiness. Now, let me tell a longer story about the eventual end of the Sun, our life-giving star that has nurtured us for ages. In about 1.1 billion years, the Sun will shine 10% brighter than today, but that heat increase will cause Earth's oceans to evaporate slowly, the atmosphere turning scorching like a furnace, seas drying into white salt basins, and our planet beginning its transformation into a harsh world. Imagine Earth then, endless deserts, howling hot winds, no more gentle waves or pattering rain. After 3.5 billion years, the Sun will turn Earth into a Venus twin, thick carbon dioxide atmosphere, hundreds of degrees Celsius temperatures, crushing pressure, hellish surface with lava rivers and murky yellow skies. Then in another 1.5 billion years, the Sun exhausts hydrogen fuel, swelling into a red giant. Two scenarios: Earth swallowed in blazing plasma, vanishing in an imagined roar, or flung into cold space as an eternal ice ball under faint stars. Finally, after 5.4 billion years from now, the Sun expands 100 to 200 times, engulfing inner planets, then shrinks, ejecting outer layers in glowing gas clouds. Left is a tiny, scorching white dwarf, erasing all human traces. Cities, forests, oceans, all dissolved into nothingness, leaving eternal silence in space. This timeline, based on stellar evolution models, underscores the need for interstellar travel to ensure species survival. But dangers are not just distant future, rogue black holes could be lethal now. Imagine a tiny one, a few kilometers wide but sun mass heavy, sneaking through the Milky Way at high speeds. Scientists estimate 500 million such objects, undetectable due to size, a solar mass black hole just 6 kilometers across. If one nears Earth, instant end, swallowing the planet, spaghettifying everything with gravity, or disrupting orbits, freezing us far from the Sun or roasting close. Winds howl, ground shakes, skies shatter, a nightmare we have luckily avoided. Detection efforts use gravitational lensing and microlensing surveys to map potential threats. Now, a fun fact about our home: why call it Earth when oceans cover 71% of the surface? It should be Water World. See the globe spinning, Vast blue seas glistening under sun, waves crashing, dolphins leaping. But do not be fooled, total water is surprisingly scant. Shrink Earth to handheld ball size, all oceans a tiny droplet, less than 1% volume. Cross-section shows molten iron core, dense rock mantle, thin water shell, precisely 0.12%. This makes you cherish every raindrop on rooftops, every babbling river through green forests. Conservation becomes vital, as fresh water is even rarer, mostly locked in ice or groundwater. In just 1 second, the universe bursts with wonders. Pause and feel, Earth struck by lightning 100 times, thunder booming like heavenly drums. For babies born somewhere, bringing fresh hope, 2 people pass away, leaving quiet sorrow. Our planet races 30 kilometers around the sun, over 1,000 stars explode in supernovae with light billions of years old, 3,000 new stars born in shimmering gas clouds. Galaxies shift over 1,000 kilometers toward great attractors. The sun generates energy 1,000,000 times humanity's yearly needs in bubbling plasma, and in Vietnam, we consume 315 kilograms of rice in that instant. These statistics, drawn from astronomical data, illustrate the dynamic cosmos we inhabit. The idea of sending trash to the sun for burning sounds appealing, but reality is complex. We produce billions of tons yearly, towering landfills with foul odors, and launching 1 kilogram costs 200 million to 1 billion Vietnamese dong. Largest rockets carry 100 tons per flight, requiring hundreds of millions of launches, staggering expenses. Even if possible, rocket exhaust would ravage the ozone layer, holes widening under harsh sun. One failed explosion scatters radioactive waste like toxic rain, poisoning soil, blackening rivers, catastrophic for generations. Better solutions involve recycling, reduction, and advanced waste-to-energy plants on Earth. On Jupiter, the solar system's largest storm, the Great Red Spot, behaves oddly. Jupiter, oldest and biggest planet, twice all others' mass combined, with swirling orange-red cloud bands. Observed centuries via telescopes, imagining winds at 400 kilometers per hour. The Great Red Spot, centuries old, once fit 3 Earths, but since the 1800s shrinks 1,000 kilometers yearly, now Earth-sized. Scientists worry, studying nightly with Juno orbiter snapping turbulent clouds, before it vanishes, leaving planetary climate change mysteries. Juno's data reveals deep roots and chemical compositions, aiding weather models. Farther out, the oldest known planet Methuselah redefines cosmology. Big Bang 13.8 billion years ago, this formed just 800 million after, thrice Earth's age. Orbit's harsh binary, pulsar spinning fast emitting deadly X-rays, white dwarf supernova remnant. Survived explosion, 12,400 light-years away, 2.5 Jupiter masses, surface likely scorching rock or solidified gas. Hubble discovery and 2025 updates excite astronomers, proving rapid planet formation in early chaos. It challenges formation theories, suggesting disks cool quickly. Back to Apophis, no asteroid approaches Earth this close in millennia. In 2029, passes satellite close, naked eye visible as moving bright star. Simulations showed near keyhole miss, altering for 2036 hit, but new data eliminates risk. Radar observations refine orbits precisely. On universe scale, common images mislead, Earth-Moon separation 30 Earth diameters, real sun distance 147 million kilometers in Goldilocks zone for liquid water and breathable air. Solar system vast, planets billions kilometers apart, Voyager 1 exited 2012, reaches nearest star in 73,000 years. Milky Way over 100 billion stars, universe over 1 trillion galaxies, vastness humbling under night sky. Scale models help visualize, like placing planets across continents. Finally, the most terrifying photo from astronaut Bruce McCandless, in 1984, first untethered spacewalk, 100 meters from Challenger at 290 kilometers altitude. Only spacesuit and nitrogen thruster backpack, black void around, blue Earth below, teeth chattering from cold. Equipment worked, Safe return after frightening free flight. 40 years on, image symbolizes exploration, reminding courage and NASA tech progress, with labored radio breathing and infinite loneliness in space. It inspired safety improvements in extravehicular activities. Artemis is more than science, it is a tale of hope, bravery, and endless curiosity. As rockets launch, their thunder will echo in our hearts, inviting you to look up at the night sky and wonder, what comes next? Let us watch together, for the universe is calling, and we are answering.